Let's think about this. Why does an aircraft fly? Well, the answer is extremely simple. The aircraft flies because the lift is equal or larger than the weight. Okay, we illustrate this a bit. We have the aircraft here, and this aircraft has a weight. And we symbolize this weight, which is a force, with an arrow pointing downwards. We call this the weight. In order to lift up this weight, or to make it fly, we need a lift. This is a force opposite to the weight of equal or larger magnitude. So in this particular case, we have a situation where our lift is obviously bigger than our weight, which makes our aircraft climb. If our lift was equal to our weight, the aircraft would maintain its altitude. And obviously, if our lift was smaller than our weight, the aircraft would descend. Alright? So, why does this aircraft fly? Exactly, same answer. The weight acting on this aircraft downwards is countered by an equal but opposite directed lift. And that makes the aircraft fly. This pilot chose to use his Martin Baker ejection seat to leave the aircraft in distress. Now, why does he fly? Simple answer. The pilot and his seat got a weight. And, sorry, I have to redo this. And don't be fooled, this weight goes straight down towards the center of the earth. This is his weight. Now, since the ejection seat with the pilot has detached from the aircraft, it doesn't have to do anything with the aircraft anymore. No contact, no relationship anymore. Now, his ejection seat has to produce a lifting force equal or bigger than the weight in order to fly. But since the ejection seat is accelerating away, climbing away from the aircraft, the lift in fact must be bigger than the weight. But this is the case here. So lift is larger than weight. This way the ejection seat with the pilot inside can accelerate away or climb away from that aircraft. Why does this aircraft fly? Well, same answer. Lift is larger than weight, or equal to weight. Now we must be very careful. The weight always goes perpendicularly downwards towards the center of the earth. So it looks a bit odd that the weight goes this way, but it's true. And if you look at the hair of this pilot, they would hang down, pulled down by their own weight. Now, in order to make this flight, we need to produce a lift equal or larger than the weight. Why do these balloons fly with the little man on the bottom? Well, the man got a weight. Doesn't look much overweight, so maybe this is 550, 600, 650 Newton. Sorry. Pointing this direction, his weight. The balloons produce a lift equally but opposite direction which counterbalances the weight and makes the man fly. Why does the kite fly? Well, the kite has got a weight, and here we need to add the weight of the string as well. And thanks to the wind, we can produce a lift, and we will learn how we do this. And this lift must be equal or larger than the weight. Why does a brick fly? Well, you will say the brick doesn't fly. Let's have a look into it. So the brick obviously has a weight, but there's no lift. So we can claim here lift equals 0, which is good for engineering purposes. Aerodynamically there is a little lift in fact, but never mind. So lift 0, weight is larger than 0. Consequence is our lift is smaller than our weight. Our brick needs to descend. And that's what it does. So does the apple. This is supposed to be Mr. Newton, Isaac Newton, and the apple falls down because the lift is smaller than the weight. Now why does this aircraft fly? Exactly, lift equals or larger to weight. Now when we draw the weight and the lift here, we must be very, very careful, because we remember weight goes down vertically. So our weight goes this way no matter what attitude the aircraft has. And consequently, the lift must go in the opposite direction no matter what is the attitude of the aircraft. There are other components of these forces which we are going to deal with in later problems of this module, but weight goes perpendicularly downwards, lift opposite direction upwards. Next one, that's a helicopter. We typically see this attitude of the helicopter during takeoff and initial acceleration, and we have the same story again. There's a weight in this way, and now we need an opposite force, the lift, and since the helicopter is taking off, means its ascents, it gains height, the lift needs to be larger than the weight. And that's the way it is.